All right, you guys, section 3.3 for pre-calculus. First thing is need to motivate for you that on your calculator, you have a log base 10 button and a log base E button, otherwise known as the LN button, natural log button. If you want to type in something that's a base other than base 10 and base E, there's something you can't type it in because you have base 10 and base E. So to motivate how to do it, I'm going to show you a rationale on why it works. Because again, I always think it's important to know why you're doing something and not just do it. Now, before I go much further, I'm just going to jump down here and get ahead of myself. This rule right here that you can learn in a few minutes says that if you have an exponent inside a logarithm, that exponent can drop in front and multiply times the logarithm. So log of a raised to the b becomes b times log a. Now, I haven't explained why that works, but you need that in order to do this explanation. I translate this, it becomes 5 to the x is equal to 7. Now, it's looking for what's the exponent in 5 that gives you 7. That's what this wants. 5 to what power is 7? Okay. As an analogy, let's say I have x squared is equal to 17. To solve that, I would do something to both sides, and as long as I do the same thing to both sides, it's legal. Because I have a log base 10 button on the calculator that's available, I'm going to take the log of both sides. This exponent, based on that rule I showed you just a minute ago, is going to drop in front. So I have x log of 5 equals log of 7. I want to solve for x. That's held by multiplication, so I'm going to divide it out. This, if you type it in your calculator, gives you the exponent that goes on, where'd it go? 5 to what, whoops, 5 to what power is 7? Typing this in your calculator will give you this answer. What's the exponent on 5 that gives you 7? And I wish in the software I could call up a calculator and let you see it, but I can't. The one tip I can give you when you type this in, be sure that a parenthesis shows up. Be sure and close that parenthesis before you hit divide. It's not necessarily necessary to close this last parenthesis. You can hit enter at this point, but if you want to be thorough, you can close it and then hit enter. But that last parenthesis isn't needed. It's this one here that you want to make sure is happening. If you don't, what's going to be typed in is log of 7 over log of 5. That's what you'll end up typing in, which isn't what you want, but that will be inside the logarithm. Okay. What you need to see is here's the original question. What ends up getting typed in the calculator is the log of that number over the log of the base. So log of 7 divided by log of 5. So what would you type in for this one? Log of 5 divided by log of 4. This is base 10. There is no change you need to do. You can already type that in your calculator. This one, you would type in log of 8 divided by log of 3. And again, those are base 10, so it's just the log buttons on the left side of your calculator, just type it in. Again, trying to trick you here, this is already base 10. You don't need to do a change of base to type this in. This one, you type log of 816 divided by the log of 5. And that'll give you the exponent on 5 that gives you 816. This you type in log of 6 divided by log of 8. This one, log of 12. Whoops, said it backwards. You guys are just trying to see if I can do it right. All right, log of 256 divided by log of 12. Okay, so that's called, again, change a base. That's how you change the base so you can type it in your calculator. Down here, there are 3 rules that we need to go through. One of them we've already talked about. When you have product and the bases are the same, you add your exponents. That's a rule for just numbers that you already know. When you're multiplying inside a logarithm, sorry guys, I'm going to cough and get a drink. 1 sec. Sorry about that interruption. Okay. When you have a product inside a logarithm, you can break it apart into a sum of logs. When you're dividing inside a logarithm, you can break it apart into a difference of logs. And then this one, we already looked at, you can drop that exponent down in front so it's a product. There isn't any motivation here on why these ones you'd want to do it, but I'm just giving you the examples of what you might see in your homework. It says use the properties for logarithms to rewrite these logs. Okay, this is a product inside a logarithm, so you'd have log of 5 plus log of x, and you're done. There's nothing to do. You just, next problem. This one is log of 5 minus log of x. This one I'm trying to trick you. It's when you're dividing inside the logarithm, not when you're dividing logarithms. So nothing happens here, nothing simplifies. And you may be a little stumped on this one. That's log x, and a square root is the same as an exponent of a half. So this would drop in front. This is identical to 1/2 times log of x. Okay? That's the same thing as log. Well, yeah, okay, sorry. I was, never mind what I was thinking because it was a mistake. This 1/3 would drop in front, so this would become 1/3 log of 6. This one I'm trying to trick you. It's when there's a division inside a logarithm, you can break it apart into a difference. Here, there's no rule. When you have a difference inside the argument of log, you can't touch it. There's nothing that happens. It's as good as it gets. That, the 3 just falls in front. Okay, now this one is definitely a little bit longer. The main thing that's going on here is this quotient, this fraction. So you first start out log base b of x squared minus log, and I'm going to put a paren around this, y squared z cubed. Now inside this logarithm is a product. Now to try not and get these things mixed up, this is its own separate thing, and I'm going to work with this and then have it subtracted from it. So it starts out log, whoops, I forgot the base b on this one, sorry about that. Log base b of x squared minus all this stuff. So it's going to be log base b of y squared plus, because it's a product, log base b of z cubed. Now if you remember back up, there was the rule that says if you have an exponent inside the argument of logarithm, it drops in front as a product. So coming back down to this, all of these exponents can dump in front of it. So that's going to be 2 log base b of x minus 2 log base b of y plus 3 log base b of z. Heck of a b. Okay, now the last step is you're going to take those brackets off, which are just like parentheses, 2 log base b of x minus 2 log base b of y minus, because that subtraction is distributing through, 3 log base b of z. Okay, going on to the next page. If you already have a difference, it's asking you to bring it back from whence it came. So this would be log base 5 of 125 over 5, which is the same thing as log base 5 of 25. Now pause there for a second. 5 to what power is 25? Or you could say it this way, what's the exponent on 5 that gives you 25? Okay, so the answer is 2. This one, log base 5 of 150 over 6 is log base 5, once again, is 25. So the answer, again, is 2. This one, you're subtracting again, so it's another quotient. Log base 4 of 2 over 8 is log base 4 of a quarter. Now, another way to write this, in case you're not seeing the answer, is log base 4 of 4 raised to the negative 1. Now just think about it for a second. It says 4 to what power is 4 to the negative 1? Said another way, what's the exponent on 4 that gives you 4 to the negative 1? The answer, negative 1. You can get that right from here if you just slow up and think about it. 4 to what power is a quarter? Or what is the exponent on 4 that gives you a quarter? Negative 1. Now, needing to talk about ln and e when it's in the argument, this really says log base e of e cubed. Now slow down and think about that. What's the exponent on e that gives you e cubed? Or e to what power is e cubed? Well, that's just 3. Log base e of e to the 7th. What's the exponent on e that gives you e to the 7th? Well, that's 7. 3 minus 7 is negative 4. So another way to say this is when you have the ln of e, it cancels out. And so you have 3 minus 7. It's kind of like saying the square root of x squared. A square root undoes a square. An ln undoes an e. Okay? This one, there's nothing really to solve on this. It's just rewriting it using the rules. It's 4 to the 1/3. Or if you want to write it, there's no requirement to do this. Log of the cube root of 4. Okay, I would take either one. This just pushes up. Log of 4 raised to the 2/3 power. Okay, a little bit longer. Okay, log of x squared plus log of y cubed minus log of z. This sum becomes a product and the difference becomes a division. So writing it as one big old logarithm, you've got x squared times y cubed over z. Okay? This, it's not really one of the properties, I just want you to think about it. 5 to what power is 0? 5 to what power is 0? 5 to what power is 0? There's no answer to that. There isn't a number that you can pick that gives you 0. Okay, so there's no solution to this. This one, however, 16 to what power is 1? That's 0. Okay? If you wanted to do a change of base and type it in your calculator and check, log of 1 over log of 16 is going to give you 0. Okay? I believe that's the end of it. Let me scroll down. Yep, that's the end of it. I don't think there's another page. So that's the end of 3.3.